data. So that's the idea of the cache in the file system. So we can use the buffer cache for that. There are just like the communication methods, synchronous or asynchronous. Which one will be better? The asynchronous will be definitely better. Whenever the disk controller requests to read the data, it's not synchronous. Synchronous is the confirm to return the data. Then again the request, but most of them are asynchronous. The problem is I didn't cover the memory management yet. Okay. However, so later, the next week, week after Thanksgiving, we will see. But very simply, shortly, memory also use the cache. That's the idea. Okay. When you read the file information, so your process asks to read the data from the hard disk drive. Then your processor will be I/O wait state. Then when disk controller return the information, where it goes? Directly to the register or CPU? No, it's going to be stored at memory. Okay. Then if you map the memory address to the file I/O, then that is called the memory map I/O to reduce the overhead. So at that time, to speed up, we will keep the cache, memory cache, okay? Another cache. So there are two levels of the cache. One is the cache for file system. Another one is the cache for page. Page we will see. That's the data structure, the unit, I/O unit, the data structure for memory management. So there are two levels of the cache. Is it a problem? Very complicated, right? Which one is cache of cache? Even it's not cache of cache. This one is for the file cache. This one is a memory cache. But the data itself is the same. So to address such a complex situation, most of the operating system consider the unified buffer cache that contain both files cache and the memory cache. If you want to discuss or talk, you can go outside. Okay. So that makes the delay of the lecture. Then we cannot have the quiz today also. Excuse me. If you want to talk, please go outside. Okay. Please. So that helps us to save the time. So this is the buffer cache. So that buffer cache will be used for both memory and the file system cache. Okay, two-level cache is really complicated. Even the cache, managing cache is not that easy. By the way, have you ever thought about how to manage the cache? We talk about the cache a lot. How to manage the cache? What is the idea of cache? We can keep the previously accessed data in the faster device, right? Which means not all the data, only few of them are in the cache. Then this is a copy of the original data. So we should be careful to manage. This is a very limited space, but should be faster to find it. Then how can we manage the cache? Idea is if accessed, think about your desk in your room. If you use a lot of for example, this one, probably is nearby your desk. If you do not use the textbook a lot, textbook will be somewhere in your room. Which means, if frequently used, nearby, and otherwise, the far. So you can use the least recently used algorithm. It's a very popular algorithm. Most of the cache use the LRU algorithm, least recently used algorithm. It's kind of a list. The frequently used one is the top, and not the other. So you can just check from the beginning, because that frequently used. If you recall your idea of the data structure, linked list. Okay, some variation of the linked list is the data is accessed and going up to the linked list, right? Then the frequently accessed data will be top, and not accessed data will be end of your link. So that is the idea of the linked list to manage the buffer cache. So we can use the unified buffer cache to address problem of the double buffering. Okay, then another issue of the file system is, what if when you are using the USB, have you ever thought about why we need to save remove every time? This one is not, right? You can just take out. But the Windows is always ask the save remove. What happens when you click the save remove?
Checks for
It
the
checks
file.
to see what's open and closes it.
And also, some of the data are still in the cache. So because as we have seen, it uses a lot of the cache and such a data, change data. If you just read on it, even though you just pull out your memory disk, it's not a problem. But if you write the file or copy the file, change the file, it is copied to only the buffer. Okay, it's not flushed to the file system yet. Why? First question. Why the operating system, file system do not write? That is called the in-place writing. When you write the data, it's the same problem. So most of the program, the PFS manage such information in your program memory, but should be in the file system, persistent disk. Then why do not write directly to here?
Overhead.
It's overhead, huge overhead. Okay, so most of the writing to the hard disk drive or the file is not the in place the writing. Instead, it write to the memory first. Then from time to time, we write back to the hard disk drive. Problem. So it's okay. So buffer. So 1, 2, 2. But it's in the file. This is a file system. It's still 1. So if you safely remove, this will be applied to the 2. So no problem. However, I write the file and even the close the file still is a 2 in the memory but 1 in the file. Okay, then your system is down. Because of that, the USB sometimes cannot read the data. However, what about this is a database and the company? You will lose the very important information, right? So to address that, to make the consistency of your system, we need to address this problem. So this will be discussed in detail in the database class, but in short, idea is we are going to use the log. So log means, what is a log? Or sometimes it's called the journaling. Journaling means keep track of any activity. So this is called write ahead log. Whenever we change the value, write the data, modify the data, create the file, writing, not read only. Whenever you have such a writing, right? Then first we write the memory. Then logging this activity, change it 1 to 2, this information to the log data. Okay. But problem is this log should be persistent disk, file system, not memory. Okay, then this is still the 1. This is a 2. This is a 1, 2, 2. Changing. Okay? The command. Then when the system is down, you lose this data. You lose this data, but this will be okay. Then when you turn on, this one is still 1. But you can check the log data. Log is survive. It's alive. So 1 to 2. It's supposed to be 2. But it's still 1. You need to recover, restore this information. So you can recover. Because of that, some of for example, when you forcibly shut down your system, it may take a time, right? The reason is that log and the real file check whether this is consistent or not. So it will take a time. It's called instance recovery. So instance recovery can be used to keep the consistency. This is not critical sometimes. You may lose. So I can type it again. So report. But it will be critical in the they are the system, like the critical system, like the database. So database use a lot of the such a recovery method. At the time, there might be the something unit of the such a operation that is called the transaction. So transaction comes from this consistency level. We will talk about the more in the database class, that the recovery and the transaction. So this is a log structure used in the file system. Even the file system uses such a write ahead log. So one more thing, keep in mind the log should be in the persistent disk. So you should not lose such information. Okay, so then the topic of the file system is it's a network file system. Network file system is based on what? So networking. So nowadays mostly we are using TCP/IP based. So it's one of the important part of the network file system is the transparent. Transparent means it should be reliable, and you may not realize it's abstract, but it should be transparent, so reliable. So you can access the data from the other remote server, or else if you are using the local server. That's the transparent. So you can use either UDP or the TCP. What's the difference? Yeah, what's the difference? Please check that we already discussed in the process communication. So we can use either TCP or the UDP. Then the NFS. So nowadays, let's quickly, we already discussed about the NFS. Nowadays, the NFS has the version 4. But last time I probably mentioned version 3. It's a current version is a version 4. The higher version provides more the higher level of the transparent as well as the security. So nowadays the security, NFS was one of the big hole of the security. But the specific protocol used in the NFS network file system is the RPC. Oh, by the way, NFS was provided by the Sun Microsystem. Nowadays, Sun Microsystem is part of the Oracle. So, but still, we call the NFS is from the Sun. Okay, so they are using the RPC. RPC protocol, I think that we have seen that before in the process communication. So it's nothing special. What about the mounting of a mounting? So for example, so this is an A server, and this is a mounting point and the mount. So it will be an NFS. Then if you mount C mounting point, so this is like this. If you mount this one, then there is no problem. You can mount network file system of network file system. Then you can when you access this file, going to B and going to A, then finally you can access the file without any of the problem. So that is the next two slides. And then also NFS support the VFS, virtual file system, which means it's an interface to use a heterogeneous file system. So from the user point of view, you may not realize they're using the different file system. Okay? I'm going to quickly skip the example. Then, what time is it?
It's 10:20.
10. Okay, so we will have the quiz for the chapter 11. One more time. The final exam is 10:45 to the 12:45 on Monday, December 11th. So please keep in mind the final exam schedule. What time does it then? 10:45. Okay, let's quickly have this. It's 11. Okay.